Hello everyone, this is Dan Jenkins from Steel Camel. Thanks for watching. We're here in the Steel Camel offices and we're going to talk to you today about dry boxes and keeping moisture sensitive parts dry. Here at Steel Camel, we're really focused on preventative maintenance, we focus on accident prevention, and we focus on productivity. So the dry box is very important to making sure your stuff works when you need it to work. And we're going to talk about different types of moisture sensitive devices. So let's just pull out a few. Okay, so I got a couple dry boxes here and I'm going to pull the first one out. Nice lid. And so the first one today is a toy gun. It's actually a toy gun because I'm not into the gun market, but this has bullets, ammunition, powder, mechanical devices, different metals, so this would be definitely considered a moisture sensitive device. There's one. Two, good old printed circuit boards, full of moisture problems, full of holes, full of dissimilar metals, different plastics, a lot of lamination, definitely a moisture sensitive device. Third, if I could find it on our table somewhere, we have meters and monitors. So this one is just a simple temperature and humidity monitor, but it's got a battery in it. It's got electromechanical parts. Definitely sensitive to moisture. Finally, we have 3D printing filament. Gets hot and cold, stretches, cracks, bleeds. Definitely moisture sensitive. So we gotta protect them. We gotta keep them, the elements out, and so they're called dry boxes. So I'd like to talk to you more about dry boxes. So what do we need to know about dry boxes? First, we need to understand how much water or how much water vapor can transmit through the glass or through the seal. That's big in the pharmaceutical industry. That's big in the circuit board industry when they put stuff in these moisture barrier bags. So the big thing they want to know is moisture vapor transmission rate. Again, is how much water can go through this thing. If you were selling drugs, you wouldn't want moisture to get into your drugs and cake them up. Secondly, we'd like to talk about the seal. So this box, whoops, has a nice seal. It comes down, it's got a nice clamp. I'll show it to you in a second. It's got a nice clamp. That's a nice seal. Some of them, like this one, has a nice seal too. I like it. I actually get them at Walmart. They're not too expensive. Get them off Amazon. It's tight. It's tight. It's got a decent amount of protection. You bang it around. Third, I really like this one. This is called the Camel. Comes out of the food industry. It's got a really tight seal. It's really tough. You can bang it around, and which is really important, you can see through it. So if you really want to pay attention to your dry box, I like the clear ones because you can see when condensation is forming. This one's called a Camel. Very nice. And there's some other ones. Get them off Amazon. These are cheapies. These have seals and clamps. Okay. This one's got some different types of desiccants in there and different types of scales, but it's got a clamp. I don't like it because you gotta line it up and you gotta listen for it, and they pop off all the time. So I really don't like the ones with these types of clamps. So now that we know that, we want to talk about what's so bad about condensation. So I got this little chart here for you. I'm gonna pull it out for you. The first part, excuse me, is right here. We have products that fail. What causes them to fail? Moisture. So moisture gets in there, causes corrosion. Secondly, we got heat. When you get heat, hot, cold, the product expands and contracts. Therefore, you get open the grain and moisture gets in there. Third, if you got electricity, you got voltage and you got current. If it's damaged by corrosion, you become unstable or instability. And finally, the other thing that the dry box does, it keeps the contamination out. And contamination mixed with moisture is a recipe for failure. Okay, So let's get a little deeper into condensation. So we know when we take a shower, we touch our mirror, it's wet. The gas is condensed on the mirror, and it's wet. I took this picture right here in Miami, Florida. I'm one of these science nerds that walks around downtown Miami at night looking at moisture and condensation. But I walked up and down this avenue. It was hot outside, it was humid, it was 95 degrees at night, but all the ice cream stores and the restaurants were cold inside. When you looked on them, there's condensation all over the glass, okay? And it's that condensation that falls on your parts that causes the damage. So let's now talk a little bit about contamination. You saw it in the chart, ionic contamination. So we've all heard about salt water. That's a contaminant. Yes, very acidic, very nasty. What are some other ones? So we have just general pollution from our cars, general pollution from smog. It gets into our dry boxes, mixes with the moisture, causes problems. If anybody works near a gas station or a power plant, you'll see that petroleum and gasoline is a bad vapor mixed with moisture, causes damage. Some other ones, human sweat, fertilizer. If you're in the circuit board industry, some of the rosins, some of the flux, they mix with the moisture and they cause contamination. Bad stuff. Okay, so let's go back to heat. What's wrong with heat? Why is it so important to keep these in a cool, dry place? What's so bad about heat? Heat, again, expands and contracts, and the gas has to go somewhere. So the only way it can go is up. And when it goes up, it pushes up against the laminate, it pushes up against the parts, and it creates damage. So those are some real things why we have to have dry boxes. Now let's talk about some harsh environments. What are a few harsh environments? Give you a good one. So if you have your product in a dry box, but you put it in a warehouse, the warehouse gets hot, cold, expansion and contraction. What if you put it on a plane? Plane goes up, it's very cold up here, comes back down on the tarmac, it's hot, goes back up, hot, cold. Extreme hot and cold gets a lot of condensation, gets lots of damage. Finally, if you work in the military or you ship from Asia, excuse me, you're gonna have to put something on a ship. And when you're in a ship, it's hot, it's humid, it's dank, and you have dampness. So you need dry boxes and you need a way to keep your moisture sensitive parts. Let's just review really briefly why we put the lid on. Okay, so the lid protects us from the elements, protects us from ants, snakes, frogs, protects us from dust. It's really nice because if it gets hot in here, the vapors will escape and go out. But if we put the lid on nice and tight, it still gets hot in there, we still get condensation, we still get gas, can't get out, hits the lid and falls back down. That's why if you look inside of a gas tank, you'll see condensation. Or you look inside of a wet dry box, you'll see the condensation on top and it'll drip down. It's trying to escape, hits the lid, comes back down. So the lid is very important, okay, because it keeps the elements out, but it also keeps the condensation in. So now that we know about the lid, we know about the box, let's talk about keeping them dry. Let's talk about desiccants. So first one I'd like to talk about is this guy right here. Basically dried sand. Some people call it silica. Some people call it a molecular sieve. Basically dried sand, pelletized. Looks just like that. Basically little marbles. Next one is called clay. Some people call it diatomaceous earth. Basically made from old dinosaur bones. And it does absorb moisture, okay? Third is called a polymeric. Most people are familiar with diapers. Most people wore diapers or changed diapers. They know anything about diapers. The moisture will stick to the diapers and it will expand. It will actually get big and heavy. But the problem with the diaper is two things. A, it stays wet. And B, it cannot pull moisture out of the air. So right now I'm going to add a little water and we're going to see what happens to these products when you add a little water to them. A little water. A little water. We'll come back to that in about 60 seconds, see what's happening. So these are different types of desiccants. Again, the silica gel, the clay, and the polymeric, and they adsorb or absorb water. So adsorb is the water basically sticks to something. The water's still there. So as you can see, the water's still there, but it's stuck to the beads, okay? Adsorb, the water's still there, it's just stuck to the clay, so it's still wet. So I put my hands in there, it's definitely wet. Let's look at the polymeric. It's absorbed. The water has become one, and the product actually is holding the water. In the case of this one, the polymer, it's actually dry, and it's not dripping, okay? So that's kind of cool. So this one keeps it dry. These ones lower the humidity, but it's still wet, the water's still there. So if you're into mold and mildew, anybody's into infection control, you have microbial growth, it's important to keep it dry, okay? Where these don't do a very good job of keeping it dry. Now let's review a little bit what we have. So we have how much can penetrate, moisture vapor transmission rate, how much air can we do, the types of desiccants. We're all trying to keep this box dry, okay? How much desiccant? Do we put one small bag? Do we put small bags like these? Or do we do jumbo bags? Should we do small bags? So we don't know. So when we test, we got to look for how much desiccant we have to use. And then we have to ask ourselves, how long do we want to keep our parts dry for? So for example, let's say we're building an airplane for the Air Force. Well, they want you to keep parts around for 10 years, okay? Or we're at a museum, we have Cleopatra's jewelry, very expensive stuff. We got to keep it around for a long time. So we got to measure how long it lasts, okay? And finally, we need to know a little bit about the environment. Are we going to be stable, or are we going to be hot and cold? I work with the United States military. They go into a lot of extreme climates, from Egypt to the jungles of Guyana, and they go up and down. The temperature goes up and down, so we got to pay attention to that. So if we're an engineer, we're faced with keeping this dry box dry, we got to understand these things, and we also have to understand how much volume of air is in here. So we could pull out our little ruler, right here, little ruler, and we could do the easy calculation, length times width times height. Not a problem. But it's not so easy, because when you look at these boxes with the products in there, now we have mass, and we have different shapes, and we have different materials, and we have wood, and we have plastic, we have metal, so it changes the dynamics of our calculation. So it's very complex to figure out the exact amount of desiccant and the exact volume of air. So you may ask, Professor Dan, how do we do it? How do we test? How do we know? How do we figure out how to keep our products dry, and how much do we need? Good question. We test. We test, and we test more. What do we test for, Professor Dan? First one we got to test for is weight gain. How much weight can a desiccant gain? For example, did these gain very much weight? I don't think so. Did that gain a lot of weight? I think so. So 1, weight gain. 2, again, hard to determine the volume of air, but do your best you can, okay? If you really, really, really want to get scientific, you'd actually fill it up with water and figure out the exact volume of available space in there. 3, you got to test for longevity. How long does it last? Nobody wants to put a part away and come back a few years later, open up the box, and the part's destroyed, particularly if it's a very expensive circuit board for an airplane, okay? So we got to test for longevity. And another thing we test for, very important, is why I chose clear boxes, clear dry containers. We have to test, we have to observe condensation. So you need to look with your own eyes inside here how much moisture is building up and how much moisture is reforming. So some of the big companies do a lot of tests. They put it in windows and they actually measure how much condensation we have. And by the way, we have some tests on that if anybody would like to see it. And finally, after you do all those internal tests, you need to ship it. You need to put it on a plane, put it on a train, put it on a ship, send it around the world. Okay, put it in different environments and monitor how much condensation builds up in the dry box and which bags are most effective. So having all said all that, dry boxes can remain dry if you pay attention, do your homework, do your tests. If anybody would like to see some of the tests that Steel Camel's done, we'll leave them in the link below. We really appreciate you watching today, learning about dry boxes and how to control condensation. So thank you very much. Get us at steelcamel.com.